Hello. In this session, I wanted to go over normal distributions. A normal distribution is probably the most important distribution you'll ever learn, and many continuous variables in business and social sciences and also in physical sciences follow a normal distribution. So the properties of a normal distribution is that it's symmetric, and so that means the mean value of a distribution is the same as the median. And also it's bell-shaped, so which means there are more data points distributed around the mean and median than at the extreme values. So if you draw a normal distribution, it's kind of bell-shaped, and in this case this is your x. Mean and median are the highest point, all right, and it is it goes from, theoretically speaking, the value can go from negative infinity to positive infinity. Okay, but for practical reasons, we will we will restrict that to 6 sigma. Okay, well, we'll see what that means. Okay, all right. Now, given this normal distribution, we can then try and find probabilities. The sum of all probabilities under this curve is 1.0 as before. Now, problems will ask you to calculate probability for x following a particular range from something to some low value. So probability may want you to find, and the problem may want you to find probability for x below a certain value, or x higher than a certain value, or x in between two ranges, x between low value and high value, and so on. So problems may want you to calculate this probability or this probability or this probability. Now there is a way to do that. Now we're going to see how that works. To find probabilities, we use Z transformation. So we use Z transformation. So any x value gets converted to Z, and that is simply done by whatever x we have, and we subtract the mean from it and divide it by standard deviation. So this is called Z transformation. And once you got the Z transformation, then we use the cumulative standardized distribution table. Use the cumulative standardized normal distribution. It's a mouthful, but it's very useful table. So when I say standardized, standardized means we are using Z transformation. So the Z transformation is what we call standardized, and the table gives us cumulative distribution. Okay, so it means like summed up to certain value of Z. All right, so that's what the table gives us. And so this table, let's take a look at the table. This table is at the back of your book, and it looks like this. Okay, so that's the normal distribution, and that's with the standardized normal distribution, the mean and median is always 0, and for any given Z we can calculate the shaded area, which is the probability. So this table, if you know the Z value, you can find out the probabilities. Now these probabilities, as you can tell, goes from very low value close to 0 when Z is -6, and as you go across it keeps increasing, As you go down, it keeps increasing. Okay, and for z all the way to, for example, z 0.5 is area is 0.69. As you go down, z of 1.0 is 0.8413. Z of 2.0 is 0.9772, and so on. As you go down the bottom here, it's 0.9997. So for a z value of 3.9, it goes really high. So this table shows us the distribution. Shows us the probabilities. So these are the probabilities for z. It's cumulative probability. So it's for z of a certain value and less. So the area to the left of this line is what we get. Area under the curve, but to the left of this line is what is displayed here. Alright, given this information, we can then answer some questions about probabilities. Okay. Now, firstly, we'll see how to read the standard normal distribution table. Okay. So we look at some problems from section 6. Problem 6.1 at the back of the book, back of chapter 2, chapter 6. Sorry. Okay. This is on page 202. Okay. So the first problem is it wants you to ask what is the probability that z is less than 1.57. So to do that, you look at the table and look for z 1.5 in the margin here. So this is a negative. The next page is where we have positive z's. So these are the positive z's. Now 1.5 is here. 1.57 would be under 7, 0.07, and 1.5. So that will be 0.9418. Okay, so that is 0.9418. Okay, all right. So that is a way to do that. Problem B wants you to calculate probability of z greater than 1.84. Okay, and now the table only shows us area to the left of this line. So this is 0 is here, this is 1.84. Now the table only shows us this area, but if you want this area, to calculate this area, you find this area and subtract that from 1. That's how you calculate this. So this is some to calculate this area, you find out this probability and subtract that from 1. So in other words, this is the same as 1 minus probability that z is less than equals 1.84. Looking it up from the table, we can find that it is 1 minus 0.9677, 0.9671, and that is 0.0329, 0.0329. Okay, so that's the answer to this problem. Probability that z is greater than 1.84. So this value is 0.0329. Okay, so that's 0. All right, so that is problem 6.1b. Now the next problem 6.1c. Wants you to find probability of z between 1.57 and 1.84. So we want to find this probability, z falling between 1.57 and 1.84. It helps to draw the distribution first. So that's 0 here, and it's 1.57, so it has to be to the right here. So let's say this is 1.57, and and 1.84. So here, so what we want is we want the probability between these two values. So this is the probability that we're interested in. Now of course the table doesn't tell us this directly, but it can tell us the probability of z less than 1.57. It can tell us this probability, and can also tell us this probability. So once you know these two probabilities, so to find this area, the shaded area, you take this probability, and from that you subtract this probability. Okay, so how do you do that? So it's the same as probability of z less than equals 1.84 minus, so that's the same as probability of z less than equals 1.57. And if you notice, these are the same numbers we used in part A and B of the problem. So it's 0.9671, 0.9671, minus 0.9418, and that equals 0.0253. So this area is 0.0253. Okay, so that is 6.1C. Okay, now 6.1B is a little different. So 6.1D is we want to find probability that z less than 1.57 or z greater than 1.84. So that's what we want to find out. Now if I were to draw this out in this one, what we have is it's a number between 1.57, this value, so this is 1.57, or it should be greater than 1.84. So we want to calculate the probability of this shaded area, which is kind of to the left of this line and to the right of this line. Now this one we can calculate it two ways. One is to calculate the probability of this, then calculate the probability of this. So kind of two ways of doing it. One is to calculate this as probability of z less than 1.57, okay, and then add to that probability z greater than 1.84. Now in problems A, we found probability of this is 0.9418, and this was calculated to be from problem 1B 0.0329, and this one we can do the math here, 0.9418 plus 0.0329 plus 946, 0.9747. Okay, now so that is one way to calculate it. The other way to calculate would be to, we already know this probability here from problem 6.1c, so this was done in number 6.1c. So what we do is we, whatever value got from 6.1c, subtract that from 1, that will give us a remainder. Now 6.1c is what we have here. It's the value was 0.0253. So if you subtract 0.0253 from the number, so it's so this value is 0.0253, and so that is this probability. Okay, and once you know this probability, you subtract that from 1. So shaded area 1 minus 0.0253, and that comes to 0.9747. So these two numbers sort of match. So there are two ways to do it, and if you know the probability of the unshaded area, you subtract that from 1, and that's how you get this. Or if you do it the long way, you calculate the probability to the left of z 1.57 and calculate the probability of to the right of z 1.84, and these numbers were calculated from problem 6.1a and 6.1c, I believe, 1b, so we can add them and we can get this. Alright, so that's how you do use the standardized normal distribution table to answer some questions. Next, we will see how to answer questions that deal with some real probabilities. Okay, so to do that, we will look at problem 6.5. So 6.5 is on page 202. Alright, so in 6.5 we are given normal distribution with mu equals 100 and a standard deviation sigma of 10. Okay, and so given these, how do you find probabilities? Okay, so now whenever you have a number like this, you need to convert this to z values. So you do z transformation. So for any value of x, you subtract it, find out how far away it is from the mean and divide it by standard deviation. That will give you the z value. So remember this formula. So we will use this formula to convert whatever x to z, and then once you have converted x to z, we can use the cumulative normal distribution table to find the probabilities. Okay, so the first problem, let's look at problem 6.5b first. Probability that x less than 70. Okay, so x less than 70, notice it's not z but it's x. So what I do is I convert this one to, now this is the same as probability of x minus mu divided by sigma less than, and I do the same transformation on this one also. 70 minus mu divided by sigma is 10. Okay, so now this observation here, this expression here is the same as z. So this is z less than 70 minus 10 is 70 minus 100 divided by 10. So that would be probability that z less than equals 70 minus 10 is negative 30. Negative 30 over 10 is negative 3.0. Okay, and so that value is, if you look it up from the table, okay, the table here, and so z of negative 3.0 is right there, and that's okay. So that is negative 3.0 is 0.00135. Okay, so equals 0.00135, and so this one, to draw equivalence, let's say this is x was from 100, and we transform that to z of 0, and we're interested in x less than 70, so we chose something here, and that is so x less than 70 is the same as z less than negative 3.0. So this area is what is of interest. That's the same as this area. That's what we found out. Alright, so that is 6.5b. Alright, Next, let's look at 6.5a. So 6.5a is a little, it talks about what is the probability that x greater than 75. Now notice that we take, this is mean is 100 and this is x. Okay, now what we do is we convert that to z. We take about z, this becomes mean is 0. Now this one wants to know probability x greater than 75, which is somewhere here. So this value is what we're interested in. Now corresponding z is what we need to calculate. So we transform this to 75. So this is the same as probability of x minus mu divided by sigma less greater than 75 minus 100 divided by 10. Now of course the table only gives us area to the left of the line, so what we need to do is we need to find this area to the left of 75. So this is 75 here, and then subtract that number from 1 to get the right side area. So this is the same as 1 minus probability. Now this expression here is z less than, now this expression will be negative 25 over 10 is negative 2.5, negative 2.5. Okay, so this number, so what we do is we use the cumulative distribution table to find this expression here. So 1 minus for z less than negative 2.5, we look it up here, so that's 245, here it is, 2.5, 0.0062. okay, so it's right there, 0.0062. so 0.0062. so in that answer would be 1 minus this would be 0.9938. So that's the probability that x is greater than 75. Okay. Next we look at problems 6.5 C. Okay, we done B, A. Next we look at 6.5 D. 6.5 C, sorry. Okay, problem 6.5 C is what is the probability that x less than 80 or x greater than 110. Now if you draw out your distribution, this is x, median is 100, and x less than 80 is somewhere here, x more than 110 is somewhere here on this side. So what we want is we want the shaded area, this probability. Okay, so to find out, either you can find this probability and this probability separately and add them up, or you can find this probability in the middle and then subtract that from 1. Okay, so this looks like a little bit easier, so let's do that. This is 80 and that's 110. Now this needs to be transformed into z, so this has to be converted to z, and for z the midpoint is 0, and the 80 corresponding to z, if we apply the z transformation, so that will be 80 minus 100 divided by 10, so that will be negative 2.0. so this value corresponding to negative 2.0 and this is 110 minus 100, so 110 minus 100 divided by 10, this corresponding value will be 1.0. so what we do is we calculate z less than equals 1.0, that'll be this area. Then from that we subtract z less than equals 2.0, that'll be this area, and that'll give us this number. Then we subtract the whole thing from 1.0. Okay, so let's look this up. If I look it up, this number here, this area for z less than 2.0 is 0.0228. So this is 0.0228. That's this area. Then this area for z less than 1.0 would be 0.8413. So this is 0.8413. That is this whole area. Okay, and so 0.8413 minus 0.0228, 0.8413 minus 0.228 equals 0.8413 minus 0.0228. So this value will be so this value is 0.8185. So that'll be the answer. Okay, so this value here is 0.8185. Okay, that is how you do problem 6.5c. Alright, so far we have looked at some problems that went over how to look up probability for any given z range and also any given x range. Alright, thank you.